All right, so we're going to start by looking at this sheet. This is going to go on page 23, and when you fold this one, you can fold it to where you can see the title Transformations reference sheet, right, just like this, and we're actually going to start by looking at this part right here. All right, so we're going to start by looking at this right here, and when I typed this, and I forgot to fix this, I'm missing an extra parenthesis right here. All right, so these transformations were all done in Algebra 2, okay? Y'all made little transformation booklets. You talked about all this stuff that goes along with it. So we're still talking about them. They are very, very important. You absolutely have to know your parent functions, and you absolutely have to know all of the transformations. Okay, I'm trying to make it as simple as I possibly can, especially since it's kind of a review. But let's look at what all of these say and what they mean. So you've got transformations. These two are shifts, whether you're either adding or subtracting something, right? So we're either adding or subtracting C, adding or subtracting D. When something affects X, and I'll kind of explain to you a little bit more what I mean by that, and one way to make sure you can wrap your mind around it. But if something is happening to X before the actual function, like this right here, right, then that's going to mean it's a horizontal shift, or a horizontal anything if it's affecting X before that. Vertical shift is after f of X actually happens. Now notice when you shift up, it's plus D, and shift down, it's minus. But for X, X lies. So when it's horizontal, and when it's X plus C, you actually go to the left. X minus C, you actually go to the right. Do y'all remember that stuff? X is a liar. Okay, that's the easiest way to remember it. Then we have reflections. Okay, we're either reflecting in the X-axis or reflecting in the Y-axis. Well, this negative sign here affects Y, so it's a reflection in X. And if it affects X, it's a reflection in Y, just like what you already know about those reflections. Okay? Then your stretches and compressions, right? So if I'm multiplying something by X before the function happens, it's a horizontal whatever. And it's either a stretch or a compression. Now remember, X lies. So if the number before that's being multiplied by X is greater than 1, so if it's like 4, that's actually a compression. Okay, B is greater than 1. It's a compression, and if it's less than 1 but greater than 0, then it's a stretch, because it's the opposite of what you would think. Vertical, it is what it is, and it is what you see. Okay, so I'm going to write something down, and we're going to just talk about if it's affecting X or if it's affecting Y. So if I have f of X is equal to negative 1/2, you don't have to write this down, you can just stay with me, negative 1/2 times 3 times X minus 2 squared minus 5, okay? So when I say does it affect X or does it affect Y? If it affects the X value, that means something is happening to X before the actual function part of it is. So what is the parent function for what I just wrote down? The parent function, X squared. It's a quadratic. So f of X is equal to X squared. So if something is happening before you square it, that is affecting X. So the things that affect X here are this 3 and this 2. Does that make sense to you? If it's not affecting X, then it's affecting Y. So the things that are affecting Y are the negative, the 1/2, and the minus 5. You with me on that? If it happens after you do whatever the parent function calls for, squaring, absolute value, whatever it is, if it happens after that, it affects the Y value. If it happens before that, it affects the X value. Okay? Which means this negative sign affects the Y value, so it is a reflection in what? X. This affects the Y value, so it is a vertical compression, right? This affects the X value, and it's being multiplied, so it is a horizontal, and then X lies, so it's a compression of 1/3. This too affects X, and it's negative, which means I'm going which direction? Right 2, and then this affects Y, and I'm going down 5, okay? So do you understand the difference between affect? If you can wrap your mind around what it means to affect X or affect Y, you got this down, okay? Because with quadratics, it may not be so hard, because y'all did quadratics quite a bit in Algebra 2, but if you can do one of these, you can do them for any of the functions, as long as you can identify if it affects X or if it affects Y, okay? So let's look at the back of this. It's right here. We'll go fill in some of this stuff. So this is just the basic translations, and just them one by one. So the translation, the shift down and up, okay, that's a Y thing. So that means it happens after f of x. If it's going to go down, it's minus d. Up is plus. Oh, that's a b. Hang on. Wrong letter. There we go. Then left and right is a horizontal thing, so it happens before the function happens. If it's left, it is x plus c, and if it's right, it's x minus c. Yes? All right, so then a reflection in the x-axis means it affects y, so it's just going to be negative f of x. If it's a reflection in the a reflection in the y-axis, it affects x, so it looks like this. So this is them pretty much individually. Kind of the same thing that's on the other side, but this might be a little bit more helpful for some of you. All right, so then we have the dilations, the vertical and the horizontal compression and stretch. So in these boxes, you're actually going to write like 2 rows of things. So I'm going to write it at the top kind of small on purpose. So you probably want to do that as well. So for the compression or the stretch, both of these, when it's vertical, you're going to have a times f of x. They're both going to be some number times f of x. It's what that a looks like is what matters here. If I multiply, if it's a compression and it's vertical, that means that the a has to be between 0 and 1. And it's the absolute value of a, because I don't care about the sign. It's between 0 and 1. So some fractional piece. You can't just think of it as a fraction, though, because if it was like 5/3, that's greater than 1. So, I mean, it's not just any fraction. And then for the stretch, the absolute value of a is going to be greater than 1. So horizontal, this is where you multiply by b. So f of b times x, that means we're multiplying it by x before the function part happens. F of b times x. And since x lies, the compression is actually when the absolute value of b is greater than 1. And the stretch is when the absolute value of b is between 0 and 1. Oops. So that means that whatever you happen to see in the function will compress or stretch vertically by a factor of the absolute value of a. Whatever that number is, that's the number we use. If it's horizontal, it will compress or stretch horizontally by a factor of the absolute value of 1 over b. You take the reciprocal of it. So if it's 1/3, then it is a stretch by a factor of 3. Okay? What questions do you have? All right. Then let's look at the next piece of paper. This is going on page, 24? So you want to make sure that you understand what the directions are asking of you and that what you, oops, dang it, what the heck just happened? And what you need to write as your answer here. So it says, given each function, identify both the parent function and the transformations from the parent function. All right, so number 1, what is that parent function called? It's a cubic, okay? So it's a cubic. So that means I get f of x is equal to x cubed, right? Now show me with your arms what a cubic function looks like. Come on, everybody. Nobody's too cool to be a cubic. It's like this, right? Okay, very good. So then we got to sketch that. It's a sketch. It is not, I'm not doing any little hash marks, nothing. Just getting the general shape of it there. Those 3 things have to start every single one of these, okay? With the exception of one that we're going to do together, but I'll explain that when we get there. All right, so now there's only one thing happening. One transformation. Does it affect x or does it affect y? Y. And so that means that this represents a what? What is that? -4. Down, a shift down 4. So we can, oh, dang it. Sorry, my IDs. Down 4. Okay. It's a vertical shift down 4 are the words that go with it, but I'm not going to make you write all that stuff out as long as you know what it means. Okay? All right. Look at number 2. All right. What is the parent function that goes with this one? Square root. So this is a square root. Huh? Oh, nothing. I think I just accidentally, that dot? Oh, it's like we're going to list things, and there's just one in the list. I probably shouldn't even have put it. Sorry, that dot. All right, so then f of x, no, sorry, equals the square root of x. All right, and show me your best square root function. It's just this way, right? It's like I'm a little teapot, like this. It's starting here, so there's nothing going on with your other arm, okay? All right, so it looks like this. There's your square root function. Kind of, yeah. All right, so now here, I have three transformations happening. This is what those dots were for. So I'm going to list out 3 things. That's probably a good decision to make before you start. That way you can make sure you actually hit everything you meant to. So that 2, does it affect x or does it affect y? Y. And so it's being multiplied. So since it affects y, that means it's a vertical what? Stretch. So it's a vertical stretch by a factor of 2. Yes? All right, so the negative always means there's a reflection. So I know it's a reflection. I have to decide it's a reflection in what? Now the negative, does it affect x or does it affect y? X, which means it's a reflection in what? The y-axis. Very good. Then that 1, does it affect x or does it affect y? X. So that means it's a horizontal shift. Which direction? To the right. How many? 1. Okay. Everybody okay with that? If you can identify this stuff, you can graph any of these. Okay. It's going to be a piece of cake once we get there, but you got to make sure you can identify them from these pieces that we're doing. Okay. All right. So we're going to do a few more together. Then I'm going to have you do some. All right. So let's look at number 3. What's this one called? Quadratic. Good. So it's a quadratic. Some of us really cannot get that word out at the door there. So that means it's f of x is equal to x squared. Show me your best quadratic. Come on, nobody's too cool to be a function. All right, quadratic. Cannot get that one wrong. All right, so I have, let's see, 1, 2, 3 things to list here, 3 transformations. That negative sign, I know it's a reflection, so I can write reflection in. Does it affect x or does it affect y? Y, which means it's a reflection in the x-axis. Okay. See, if you ask yourself these questions every single time, you will get through this. That's why some of y'all struggle when you're like, I can do it in class. It's because think about the questions I'm asking. It's the same question every single time. Just ask yourself. All right, so this 1/4, does it affect x or does it affect y? X, and it's being multiplied, so that means it's a horizontal, well, since it affects x, it's horizontal. Is it a stretch or a compression? Stretch, because x lies, and it's by what? 4. Okay? And then that 6, what does that do? Y value, so it goes up 6. Very good. Okay, what questions do you have? Anybody have anything at this point? I'm sorry, what? Yes, because x lies, you take the reciprocal of it. It's 1 over b. If that was 1/4 and it was affecting the y value, then it would be a compression by 1/4. Does that make sense? Okay. All right, so number 4, what's this one called? Absolute value. Okay, f of x is equal to the absolute value of x. Show me your best absolute value. Come on. There you go. There we go. Okay, good job. Here's our absolute value. All right, and we have, let's see, 1, 2, 3 transformations again. All right, so does the 3 affect x or y? X, which means it is a horizontal what? Compression by 1/3. Because x lies, so we have to take the reciprocal. Okay. That 5, that's going to be a translation or a shift, which way? Left 5, good. And then the 2 means it is down 2. Okay. Everybody good with all that? Easy enough? Yes? Okay. So we're not going to do number 5. We're going to do number 6, and I'm going to use this space maybe for a little bit of stuff. So let's look at number 6. What is the name of this parent function? It is not linear. This is a rational function. I mean, that's not what we're going to call it. That's just the general term. But x is in the denominator. It's not linear. So what? It's not exponential. Kind of, yes, but it is the reciprocal, yes, because it's 1 over the... Okay, reciprocal. So we have f of x is equal to 1 over x, right? So what does this graph have that other ones we've talked about so far don't? Asymptotes, okay? So you don't necessarily have to draw them in your sketch. You just need to know that they're there. And your reciprocal function looks like this, right? So we have 3 transformations happening here, okay? 3 of them. That negative, does it affect x or does it affect y? Does it happen before or after you have 1 over x? Well, if I took out this part where the 1 over x is, just like here, if I took out, if I took out the x squared part of it, you see how the minus would be left behind? If I take out the 1 over x part right here, you see how the negative would be left behind? So technically that one affects y. So this would be a reflection in what? The x-axis. Now, let me show you this real quick though. If I take this parent function and I reflect it in the x-axis, doesn't it look like this? Right? That's a reflection in the x-axis. So take the parent function. If I reflect it in the y-axis, what's it going to look like? The same. Okay? So whether I reflect it in x or in y, I actually get the same thing. But it's still, I still think you need to identify if it's affecting x or y though, because the other parts of this can get confusing. Because there are more than one right answer to a couple of these things, but you just need to find a way to wrap your mind around what works and then do that. Okay? So now if you look at this 4, does it affect x or does it affect y? X. Okay? Which means that it is a horizontal, is it a stretch or a compression? Compression by what? 1/4. Okay? The fact that the whole thing's in the denominator means nothing. But let me show you this. This negative 1/4, 1 over 4x, sorry. That right there. Is it the same thing if I said this equals negative 1/4 times 1 over x? Is that this? Are these two things equivalent right here? They are, right? Which means if it's written like this, then that 1/4 actually affects what? Y. So that we could also be a vertical compression of 1/4. I don't suggest that you rewrite it this way and do that. I think if you just do it this way so you know it affects x, it makes a whole lot more sense. But I do want to point out the fact that if you end up with something like 2 over x, right, that's not actually affecting x, because this is the same thing as 2 times 1 over x like that. This, when it's in the numerator, it's not touching x, and it's not affecting the x before the x gets the reciprocal taken of it. So this would actually be a y issue. You with me on that? So if it's in the numerator, think about it affecting y. If it's actually touching the x, it's affecting x. It's the easiest way to keep the reciprocal ones straight so you don't go do weird stuff. Okay. All right, and then we have that plus 3. What happens there? Up 3. Okay. Everybody okay with that? Yes. All right. So let's look at number 7. I want you to do number 7. Okay, I'm going to get somebody to help me with this one. All right, Clarissa. What is the name of this parent function? You can do this. What is this thing right here called? It's not a cubic, but it's a 3. Cube root. Okay, so this is a cube root, which means, Clarissa, my parent function is f of x equals what? Don't overthink it. cube root of x. That's why it's a cube root, not the square root. Okay? Do you know what it looks like? Yeah, very good. All right, so this is your cube root. All right, we all agree with that? All right, so I think there's there are 4 things we need to list out here. Let me get somebody else to help me with that part. Thank you, Clarissa. All right, Michael. So give me something, one of them. Okay, we go up to, what else? Good, goes to the left, 1. Mm-hmm. Very good. What does that 4 do? The 4. Very good. Thank you very much. Very good. All right. Do y'all all agree with that? Anybody have any questions? Okay. And so you don't leave something out. I don't care what order you do them in, but if you actually go like from left to right, you're less likely to leave something off because there's always somebody who's leaving something off that you can cut. That's another reason why you want to like count them out before you ever do it. Otherwise, you might go through it and think you know, we're done with something or you're not. All right. So look at number 8. Do you know what that function is? It's not the absolute value because it's doubled. It's actually the greatest integer. It's not even the signum. It's a function that you've probably never even seen before, right? And so I tried to edit it and I couldn't, so I decided to leave it to kind of make a point here. We're not going to write out the 3 things that go here because those aren't things, I'm not going to give you this one again. But what I want you to understand is it's okay if you don't know, even if you don't know those answers, you can still figure out the transformations, okay? That's kind of the whole point. If you could do it with quadratics, you could do it with anything. So there are 3 things that we're going to list out here, right? So this negative, we're going to go from right to left, actually. What does this minus 1 do? Down 1. What does the 5 do? Right 5. Okay. And then what does that 2 do? It's a horizontal something. A horizontal what? Stretch. Because what this really is, okay, with this weird like doubled thing here, this is like 1/2 times x minus 5, right? So since I have that, that means it's that 1/2, it would be a horizontal stretch by a factor of 2. Okay. All right, everybody good with that? What questions do we have? None? Okay. All right. Let's go ahead. These have quite a few on here. We're going to do them together so we can talk a little bit more on the back here. What is this one called? Absolute value. And then so we know it's f of x equals the absolute value of x. You've already given me that. So here I have 1, 2, 3, 4. I have 4 things. So I'll get somebody to help me. We're going to have to do it with me. I don't want to give you the time. All right, so Linda, what does that negative tell me is happening here? Okay, so it's going to be reflection in what? Does that negative affect x or does it affect y? Does it affect x or does it affect y? Does it happen before or after you actually take the absolute value? Well, it's inside the absolute value, right? Which means you have to do the negative before you take the absolute value. So since you have that, that means it affects x. So if it affects x, then it's a reflection in what? The y. Okay. All right. So Evelyn, the 1/3, what does that tell me is happening? Does it affect the x or does it affect the y? Okay, so that means it's a horizontal something, okay? Well, you got half of that right. The 3 part is right. So it's a stretch, good. So it's a horizontal stretch by 3. All right, yes? All right. She is not here. All right, Twee, what does the 4 do? Good. And what does the 7 do? Up 7. Ooh. Okay. Everybody okay with all that? All right, let's quickly do number 10. This is called a cubic, right? So f of x is equal to x cubed, and then that looks like this right here. So I have 1, 2, 3, I got 4 things again. Does that negative affect x or y? Y. So it's a reflection in the x-axis. Does that 3/2 affect x or y? Y. So it is a vertical what? Stretch. It's a vertical stretch by 3/2. It's a fraction, but it's greater than 1. Then that 3 means I go where? Left 3, and 8 means I down 8. Okay, everybody good with all that? Yes? All right, good. Flip it over. So we've got, there we go. So now we're going to use the graph. We're going to actually write the equation for this stuff. So what is number 11? What is the parent function called? Absolute value, right? And that means this is f of x is equal to the absolute value of x. So since that's f of x and we're changing it, we're going to call the new one g of x. Okay? All we want to do is translate it 2 units right. So does that affect x or y? X. That means it's inside the absolute value. So g of x is equal to the absolute value of x, what? Minus 2. Everybody okay with that? All right, so then we're going to go back to the parent function. And this time we're going to reflect in the x-axis and translate 5 units up. So when I reflect in the x, that affects y. And when I translate up, that affects y. That means that it's just going to look like this, just the absolute value of x. So when I reflect that, it's going to be negative absolute value of x plus 5. Okay. Everybody okay with that? You see how easy that is? Just keep asking yourself the same questions I'm asking you. So number 12, what is this called? Reciprocal. And that means this is f of x is equal to 1 over x. So I'm going to translate it 7 units down, that affects y, and 3 units left, that affects x, right? So that means I'm going to have g of x equals 1 over 3 units left would give me x plus 3. 7 units down out here would be minus 7. We good? All right. So now I'm going to horizontally stretch. That affects x. And translate right. That also affects x, right? So everything's going to be inside of that. So g of x is equal to 1 over. Well, horizontally stretched by a factor of 3 means x gets multiplied by 1/3. And then this would be x minus 2. That's what it's going to look like. Okay. What questions do you have at this point? Anything? All righty. Let's do the next one. What's this one called? Exponential. And this one happens to be, and I know that the base here is 2. The way I know that it is 2 is that at 1, I'm at 2. So this is going to be 2 to the x power. So I'm going to vertically stretch, that's a y thing, and translate up, that's a y thing. So when I do this, g of x is equal to the vertical stretch by a factor of 4, made 4 times 2 to the x power, translate 1 unit up plus 1. Can I multiply the 4 times 2 and make that 8? No, I cannot. Everybody okay with all that? You can if you want. Yeah. All right, so then vertically compress by a factor. So vertically compress, that's a y thing. Translate 5 units left, that's an x thing. So g of x is equal to that vertical compression 1/3 times 2 to the, now 5 units left means that's going to be x plus 5 in the exponent, because you have to add 5 before you use it as an exponent. Questions? It's in the exponent. It's up there in the exponent with it. Okay. All right. 14. What? Yes. No, not a square root. What is it? Cube root. cube root, so f of x is equal to the cube root of x. So I'm going to reflect in the y-axis. That is an x thing, right? 4 units right, that's also an x thing. So everything's happening under the root here. G of x equals cube root. The reflection is going to be negative, and then I have to put parentheses here. Translate 4 units right. This is going to be x minus 4. Okay, everybody okay with that? All right, you try and write the last one, this C. That horizontal compression, that's an x thing by a factor of 1/2. 5 units down is a y thing. So since it's a horizontal compression, this would be 2 times x and then minus 5 because x lies. Now be real careful when you're doing these that it's real obvious what's under the root and what's not. Okay, because if you get a little crazy with your roots, you might be kind of saying something you don't mean to say. All right, what questions do you have? All right, so let's look at number 15. It says if this function, so if we're given this function right here, and it's reflected across the y-axis, then translated right 6 units and down 2 units, we're going to write the equation of the new function. So instead of starting with the parent function, we're starting here. And with this one, we are doing these things. Okay, so see if you can, I'm going to give you a minute, I'm going to see if you can write out this function. All right, let's look at how we want to think about this. If it's reflected across the y-axis, that's an x thing. I'm going to have a negative in there. Translated right 6 units, that's going to affect this, and down 2 units, it's going to affect this. So nothing affects that 2 as far as the value of that is concerned. But if it's reflected across the y-axis, then that means the negative affects the x, so I just have this 2 out here. Then inside of here, I have a negative because I have to affect the x, right? Then it's going to be x, all right? So I'm at x minus 5, and I'm going to go 6 units right. So what is that going to be? X what? Minus 11, because x minus 5 means I went to the right 5. I need to go to the right 6 more. So this is minus 11. Close both of those, square it. Then I'm going to go down 2 from this. So where do I end up? Plus 1. Now, 16 is asked differently. It says a function was vertically stretched by a factor of 2, then translated 2 units left and 6 units up. The resulting function is represented by blank. So it was vertically stretched, so it affects the 6. Translated left affects the 4. 5 affects this. So all 3 of these things are going to get affected here. So this g of x, you're basically working backwards. I had something that was vertically stretched by a factor of 2 that ended up with a vertical stretch of 6. So where did I start? At 3. Basically, you have to do the opposite. So if I take this and stretch it by a factor of 2, that's where I end up with the 6. Okay. Then I had something originally. I went 2 units left and ended up at x plus 4, which means I ended up at 4 units to the left. So where did I start? Plus 2. Good. And then I went 5 units up to get x to get to the minus 1. I went this far to get here. It's going to have to be minus 6. Okay, you got to think about it differently. Then you can kind of take this and do those things and see if you end up with that one. Okay? What questions do you have? Well, the original is 3, and then if I vertically stretch it, that means I've got to multiply by a 2, and that's where that 6 comes from. Yeah. Good. Anything else? We're all good? Awesome. Get that put in your ISN.